Now that we have a little better understanding of central tendency, measures of variability, and the shape of our data, let's take a closer look at outliers. Outliers are often identified through a visual inspection of our data, which is why it's so important to plot it. You may be wondering if there's a mathematical way to calculate outliers. Well, it shouldn't surprise you that there is. Outliers are mathematically defined as being greater than 1.5 times the interquartile range. To calculate the interquartile range for your data, place your data in numerical order and identify the first and third quartile. In other words, at point at which 25% of the data are below and at which point 25% of the data are above. The first represents the upper bound of what we call the lower or first quartile. The latter represents the lower bound of the upper or fourth quartile. The IQR is simply the difference between those values. Multiply that range by 1.5. Add this value to the third quartile. Any number greater than that would be a suspected outlier. Subtract it from the first quartile, and any number less than that is a suspected outlier. So let's take a look at an example. Suppose we have the following set of data, and it looks like this. So the question is 14 an outlier? There are 15 values in this data set. To find the first quartile, we need to divide 15 by 4, which is 3.75. So we count over 3.75 values from the left in the data set. The lower quartile is anything lower than 4. To find the upper quartile, we count 3.75 values over from the right. The upper quartile is anything over 7. To calculate the interquartile range, Q3 minus Q1, 7 minus 4 equals 3. Now we multiply 1.5 and by 3, we get 4.5. Outliers on the low end would be anything less than negative 0.5. Outliers on the upper end would be anything greater than 11.5. So 14 is an outlier.